Good morning, students. Today's video lesson is based on the clarification of your doubts of chapter 2 motion in one dimension, which I have asked you through the Google form. So I'm very happy to see that many of you are focusing on the important topic of that chapters, and you are not taking that topic slightly. Okay. And some of you maybe you were confused because, or maybe you did not see the title of that Google form properly. That is why you asked the question from the another chapter. Okay, but today in today's video lesson I will clarify the doubts of chapter 2 only. Those who have asked the doubts of another chapter, they have to wait for the next Google form. Till then they can watch the videos of that related chapter again. Okay, so here we'll start to clarify the doubts. Okay, so our first doubt is regarding the equations of motion. So after discussing all the doubts, I will explain this. Okay, the equations of motion, because this is very important topic of this chapter. Okay, our next doubt is the graphical representation of linear motion. So this you have to notice that ICSE board has reduced the syllabus from classes 9 to 12 in all the subjects. In physics some topics are reduced, so graphical representation of the linear motion is reduced from the syllabus. So no need to prepare this. Okay, this is the big relief for you. Clear? So no need to prepare the graphical representation of linear motion. Clear? Now our next doubt is regarding the notes. How to make the notes. Either we have to make a copy or we have to mark in the book. So I will suggest you for this, you have to make the proper notes. You have to write all the topics and the subtopics also, so that you can attempt any of the question which is related with the topic. So make the proper notes. Clear? Our next doubt is, can I derive the equation of motion in my own way, which I am finding easy to understand, and the concept would be same. So yes, you can derive the equations of motion in your own way, but I think you should not reduce the steps, and the conversion of the units is very important. Clear? Whatever is required in the equation, that derivation in the equation of motion, you have to write. Otherwise, if you will reduce something, automatically your mark will be reduced. Clear? Our next doubt is, why does an athlete can't stop immediately after completing a race? Actually, this is the question of chapter 1, and here we are clarifying the doubts of chapter 2. So this doubt will be clarified in the next Google form. Clear? Our next question is, I am not able to understand and solve the numericals of all the chapters. This you should not say, because because we are in our book, most of the numericals are given in a very easy way. Okay, so you have to see the numericals. Many solved numericals are also given in the book, so you have to try. Now you are in class 9, self study is must now in this stage. Clear? And if any particular numerical you are not able to understand, you can ask. Clear? Now our next question is, graphs between the effective length and the time period of a simple pendulum and the numericals of the time period of a simple pendulum. So this question is also of chapter 1, so this will be clarified later. Okay, now our next question is the numerical which is given on page number 60. Actually this is very good numerical, and I'm explaining, or I will solve this numerical after discussing this. Okay, our next doubt is, ma'am, I didn't understand the alternative method of the equation of motion and the graphs. So for the graphs, I told you the graphs are reduced from the syllabus, so no need to no need to prepare that graphs or the graphical representation. Alternative method of the equation of motion I'm explaining. Okay. Now the solution of equation of motion. So what is the equation of motion exactly? Actually, these are the sets of equations that gives us the relationship between various parameters that describes the motion. Now the question is that what are these parameters? These parameters are velocity, distance, time and acceleration. That means that these equation of motion help us to find out the relationship between these parameters, which are velocity, distance, time and acceleration. Okay, there are three equations for motion of the body or of those bodies which travels with the uniform acceleration. That means here we have to consider the body which is moving with the uniform acceleration. So the first equation of motion is v is equal to u plus at. Second equation of motion is s is equal to ut plus half at square, and the third equation of motion is v square minus u square is equal to 2as. Now let us first understand the variables used in these equations of motion. So v is denoted for the final velocity of the object, u is denoted for the initial velocity of the object, s is the distance travelled by the object, and time is denoted for time taken by the object, and a is for the uniform acceleration. So we will study these equations one by one. Okay, so the derivation of first equation of motion. So from the definition of acceleration, as we know that acceleration, the formula of acceleration is change in velocity upon time taken. Clear? So here we can write change in velocity, final velocity minus initial velocity upon time. Clear? By the formula only we are writing. So as we know that final velocity is denoted by v, initial velocity is denoted by u, and time is denoted by t. So here we can get the formula as is a is equal to v minus u upon t. Clear? So by changing their places, we can find it, or we can find the next step, that is v is equal to u plus at. Clear? So this is the verification or the derivation of the first equation of motion. It is used to find out the velocity v acquired by the body in time t moving with the acceleration a. Now the second equation of motion, s is equal to ut plus half at square. So what we have to do to prove this? As we know that we have studied that average velocity is the initial velocity plus final velocity upon 2. As we know that initial velocity is u, final velocity is v. So here average velocity will be u plus v upon 2. This will be equation first. Now distance is equal to average velocity into time taken by the object. Clear? So at the place of average velocity, if we will put the value of average velocity by equation 1, it will be, so the next step will be s is equal to u plus v upon 2 into time, and this will be equation 2. So using first equation of motion which we have just derived, which is v is equal to u plus at, on putting the value of v in equation number 2. So the equation number 2 will be s is equal to u plus at upon 2 into t. Clear? So from here we can solve the step. It will be 2u plus at into t upon 2. Clear? Or directly we can change the value of 2 as 2s. Clear? So here s is equal to 2u into t plus at into t upon 2. So here it will be s is equal to 2ut upon 2 plus at square upon 2. You can see here this is easy, or this should be easy for you. So after cutting this, s is equal to ut plus half at square. This is the second equation of motion, and it is used to calculate the distance traveled by the object in time t. Now the third equation of motion, and that equation is v is equal to u square plus 2as. This equation can be obtained by eliminating t between first two equations of motion which we have just derived, equation 1 and equation 2. Clear? So what we can do to derive this? This is done as follows. From the first equation of motion, v is equal to u plus at. Clear? So we can change the value or change the places, and we can find the value of t by this first equation of motion. So by putting the value of this t, v minus u upon a, in the second equation of motion, you can see here. Okay, so what is the second equation of motion? S is equal to ut plus half at square. So now we will put the value of t in this equation. Clear? So here it will be u v minus u upon a plus half into a v minus u upon a whole square. We are putting the value of t in equation 2. Clear? So here s will be, now we will multiply this and now we will solve this. So this step we will get after solving this. You can see here. Okay, so as we know that a minus b whole square will be a square minus plus b square minus 2ab. Clear? So we can put the formula here, v square plus u square minus 2uv. Got it? Okay. So now we will solve this to make or to derive the equation 3. Clear? So a to a will be cut. Clear? So what will left now? Now it will be 2a. Now here it will be, by taking the LCM, the next step will be 2uv minus 2u square plus v square plus u square minus 2uv. Here we are doing the calculation only. We are solving the steps only. 2uv plus minus, it will be cut, 2a, it will be changed. Okay, so here it will come to as is equal to v square minus u square, and this is the third equation of motion. It gives the relationship between the initial. Okay, so our next doubt is related with the numerical, which is given on page number 60. And the numerical is, the cheetah is the fastest land animal and can achieve a peak velocity of 100 km per hour up to the distance less than 500 meter. This is the information which is given in the question only. Clear? This is the information only. Okay. Now, if a cheetah spots its prey at a distance of 100 meter. Clear? So what is the minimum time it will take to get its prey if the average velocity attained by it is 90 km per hour? Clear? Actually, now I am using Hindi so that the concept will be clear. Clear? That means चीता जो है वो फास्टेस्ट लैंड एनिमल है और उसकी जो हाईएस्ट वेलोसिटी है वो 100 किलोमीटर पर आवर होती है व्हेन द डिस्टेंस इज लेस देन 500 मीटर. क्लियर? एंड इफ अ चीता स्पॉट्स इट्स प्रे एट अ डिस्टेंस ऑफ 100 मीटर, अगर चीता किसी अपने शिकार को 100 मीटर के डिस्टेंस पर देखता है, देन व्हाट इज द मिनिमम टाइम इट विल टेक टू गेट इट्स प्रे इफ द एवरेज वेलोसिटी अटेन्ड बाय इट इज 90 किलोमीटर पर आवर. अगर चीता जो है अपने किसी शिकार को 100 मीटर के डिस्टेंस पर देखता है, तो अगर वो एक एवरेज स्पीड विच इज़ 90 किलोमीटर पर आवर, अगर इस एवरेज वेलोसिटी से अगर वो रन करता है तो वो कितने टाइम में अपने प्रे या अपने शिकार के पास पहुंच जाए. दैट मीन्स क्लियर. सो द कंसेप्ट शुड बी क्लियर especially in the numericals. Okay, so here first you have to write all the values which are given in the question. Suppose first some information was given like it is the fastest animal and can achieve a peak velocity of 100 km per hour. That means don't think that it is the value which is required in the solution. It is the information only. Clear? So here is the solution of this numerical. First we have to write all the values which are given in the question. Distance is given 100 meter. Clear? Average velocity is given 90 km per hour. You can see here. So we will denote average velocity by V average. Time is to be calculated. Clear? So as we know that average velocity or the formula of average velocity is total distance upon total time. And when average velocity can be possible when the object is moving with the non-uniform velocity. Clear? So here the formula of average velocity V average is total distance upon total time. So average velocity, now we will put the values which are given in the question. Average velocity is given 90 km per hour. With the unit you have to write all the values in the numericals. Clear? So 90 km per hour is equal to total distance is 100 meter upon time is to be calculated. Clear? So here you have to see that distance is given in meter, but the average velocity is given in kilometer per hour. So first we have to change it into meter per second, because we have to find the time and time should come in second or hour. Clear? So 90 km per hour should be changed in the in the meter per second, in the conversion unit of meter per second. So as we know that kilometer per hour, when it will change into meter per second, we have to multiply the value with 5 upon 18. Okay, so 90 into 5 upon 18 and directly it will be changed into meter per second, and the right side of that step will be same. Clear? So 90 into 5 upon 18 meter per second is equal to 100 meter upon t. Clear? So here we will solve this step. 5 into 5 meter per second, 100 meter upon t will be same. Now it will be 25 meter per second. Now the right side will be same, 100 meter upon t. Now what we have to find? We have to find the t. So we have to change its place. So t is equal to 100 meter will be same. At the place of t, 25 meter per second will come. So after solving this step, we got the time as 4 seconds. Now the question is that in the book, the answer is given as 5 seconds. So don't be confused. Many times answers can be wrong, or the answer key can be wrong. Your concept, your method should be correct. Clear? So don't bother about the given answers. So here time will be 4 seconds. In the book answer is given wrong. So suppose if you have solved this question and you got the answer as 4 seconds, so your solution is correct. Clear? So I hope all the doubts are clarified in this video, and in the next class we'll start our remaining portion of chapter 3. So thank you and have a nice day.